Hi. So we're gonna go on with a few more exercises. Derivative of e to the e with respect to x. Well, this is just gonna be 0 because e to the e is a constant. Okay, it's 2.71 blah 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 to the 2.71 blah blah blah. There's no x in here, so it's just 0. Derivative of e to the x. Derivative is gonna be e to the x. Okay, x to the e, the derivative of this is going to be e x to the e minus 1, right? The derivative of x to the x dx. Now, this is going to be equal. What is the derivative of this? Well, this is kind of complicated, right? Because you have x everywhere. So let's just say one thing. Let's do y equals x to the x. That means that ln of y equals x ln of x, right? Because it's going to be ln of x to the x, and the exponent from here can just come here. So because it's a property of logarithms. So there you go. Now we're going to differentiate both sides with respect to x. So you know what to do here on the left side. You differentiate it with respect to y and y to x. So you do d ln of y dy times dy dx, okay? And this is just y prime. So the ln of y is going to be 1 divided by y times y prime. It'll be y prime over y equals, and then you differentiate this, which is going to be the differentiation of the first one times the second one, okay, plus the first one times the differentiation of the second one, which is 1 divided by x. So this becomes 1, okay? So y prime equals y times ln of x plus 1. And what is this thing here? Y is x to the x. I'm just gonna copy this down there. There you go. Okay, this is plus 1. It's weird in here. Okay, plus 1. All right. Now, the book wants to talk about compound interest. Compound interest is like when you're going to have a balance in the end. You have a principal, which is what you deposit. Okay, the first money that you deposit. This kind of... Okay, I think this is better. So you have this money that you deposit here. And then what is going to be... Well, how can I explain this to you guys? The formula is going to be like this. Okay? So, for example, let's just say that you have an annual interest of 5%. That means that it's 0.05, okay? But are you going to put that it's an annual interest? So are you going to put just 5% at the end of the year? 5% more? So it's going to be 1 plus 0.05, okay? Which is the 5% of this. Equals 1.005. Is that going to be like this? Or are you going to go like, you're going to do 1 plus, well, let's say 1 plus 0.25, okay, which is half of the interest. And then when you have 1.25, you're going to make a compound interest. You're going to multiply this by 0.25. Okay, So instead of making one annual interest of 5%, you're going to make 2 of 2.5%. Or you're going to make 3 of 5% divided by 3. Or you're going to make 4 interests. Instead of 1 of 5%, you're going to make 4 interests of 1.25% each. Okay, so that's what this formula does. So this thing here is the rate. That will be the 0.05. You're going to plug it in here. The n is the number of times that you're going to compound it a year. Okay, and you got to put the same n in here. Why? Well, you see, the principal is going to be principal times 1 is going to be the principal plus the annual interest, okay, divided by the number of times that you're going to do it. Like, yeah, it's going to be the rate divided by the number of times times p. Okay, so it's the main p plus p times this. For example, let's just say that it's 2 of this. Instead of being 0.05, it's going to be 0.025. So the 0.025 is this, okay? But this is going to happen twice. So you're going to do this, and then after you have this, you have to multiply it again by 1, which is the result of this, plus r divided by n, right? So that's why you have this n in here. If you're dividing by 2, you have to do this twice. You have to multiply it and multiply it again. Okay? That's why you have this n in here. Because you gotta do these as many times as necessary. For example, let's just say that this is 2. You're gonna do it twice. So you have to multiply p by this thing twice. Okay? Okay. Now, here's the thing. As n approaches infinity, if this is 1, okay, if this thing here, I don't know, yeah, I don't think this is going to work. Just going to erase it. If this thing here is 1, and forget about this stuff, as n approaches infinity, this whole thing, the limit, approaches, right? The limit of this approaches e, equals to e. Not this is equals to e. The limit of this approaches e, right? As n goes to infinity. Okay. Now, here's the thing. Let's just say that you want, for example, let's just say that, so you have an annual interest, okay, of r. So r is going to be the annual interest. It's going to be the percentage. N is the number of times, okay? And you have this p here, okay? Well, let's just say that it's being compounded annually, all right? So n is approaching infinity, or n is infinity. It's being compounded continuously, all the time, all the time, all the time. So how much is this going to be? Well, is this going to be e? No, because e, you have to have a 1 here. So this is not e. What the heck is this? Well, here's what you can do. You can say that this equals p, okay? And you want a 1 here, so let's put a 1 there. R divided by r, 1. N divided by r, hey, n divided by r. Okay? But for this to be e, you gotta elevate this stuff to the same denominator here. So let's do that. N divided by r. Okay? So this is e. But do you want this whole thing being elevated to n divided by r? No, you want to elevate it to n. Okay? You want it to be elevated to n, not to n divided by r. So you get this whole thing in here elevated to r, because this r is going to cut with this one, and now you have n. Okay, so what is this right here, just inside the larger parenthesis? This is E, so this equals P to the E to the R. All right. So if 1 plus 1 divided by n to the n as n approaches infinity equals E, if you put an R here, this is E to the R. If you put a K here, this is a K, it's E to the K. Okay? All right. Now let's say something else. So let's say that the balance is going to be the principal, which is how much you deposited initially. Okay? And you're going to make, you have this, you have an annual rate, and you're going to compound it n times a year. So you have this, okay? And there's something else too. It's not just 1 year. This is going to happen, for example, 3 years. So you have to multiply this thing, whatever this is, you have to multiply the result of all this 3 times. You got to get this, and you got to multiply by this thing again. Okay? And then you have to multiply by this thing again if it's going to be 3 years. So it's 1, 2, 3. So what is this? It's 3n. All right? So where am I going with this? Well, if you have, this is the annual interest, and this is the number of times that's going to happen, okay? For t years, you got to multiply a t here. Because why? Because this is going to be elevated to t, right? And when you elevate everything to t, you just multiply it in here. So there you go, right? And if this is being compounded continuously, b is going to be equal to p times e to the r t. Okay? Like, for example, let's see, what is the balance, okay, after 1 year of continuous compounding, if the deposit is 1,000, so the principal is going to be 1,000 at an 8% interest compounded continuously. So if it's 8% and is being compounded continuously, it's E. So it's E to the 8%, which is R, so it's going to be 0.08 for 1 year. So you multiply it by 1, which is just 0.08, okay? So this is going to be the balance after 1 year, which is approximately yeah, 1083.29. All right. Let's see here. A deposit of $2,500, so you have a balance, and $2,500 is the principal, okay? It's made in an account that pays an annual interest rate of 5%. Okay. Find the balance in the account at the end of 5 years, so it's 5%, and for each year is going to be, for each year is going to be 5%, and it's 5 years. If it's compounded quarterly, well, if it's quarterly, we're talking about 4 months, okay, or 4 times a year, 3 months. It's 4 times a year. So it's going to be 1 plus 0.05, which is the interest rate, divided by 4 to the 4 times 5, because it's 5 years, okay? Now let's just say that it wants monthly. So instead of a 4, you're going to put a 12 here times 5, okay? And if it's continuously, well, if it's continuously, then you're not going to use this formula directly. If it's continuously, it's going to be 2,500 times E to the interest rate, annual interest rate, okay? 0.05 times the number of years, which is 5. And that's it. That's the whole idea. Now we're going to talk about inverse trigonometric functions. Okay. Now, we learned what an inverse function is. So, for example, the sine of x equals y. What does that mean? Well, x is going to be an angle, and y is going to be a value from -1 to 1, okay? So the domain is infinite, right? Because the angle can go from minus infinity to 0 to positive infinity. The range is going to be from -1 to 1. So y has a range of -1 to 1. Okay, the sine can be all that. Now, sine, the inverse of the sine is also called the arc sine. And the same thing goes for the cosine, the tangent, the cotangent, blah, 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 secant, okay? So you have all these things. The arc sine, there you go. And, all right, the inverse sine equals the arc sine. But here's the kicker. The sine is going to receive the angle and they'll give a value. The arc sine is going to receive a value and spit out the angle, okay? So the value has to be, the domain has to be from -1 to 1. So when you do like the sine inverse or the arc sine, the books using arc sine, so let's use arc sine of x equals y. The x is the value. Now what is the value of the sine? So the x in here goes from -1 to 1, okay? And the y is going to be any number, an angle, okay? So it's spitting out an angle. Now you got to know one thing, guys. Well, let's put it this way. What is the here, okay? Let's just say that this is 1, this is -1. So what is the graph of the sine? Well, the sine of 0 is 0, okay? And the sine of 90 is 1. So it's like this. Kind of like this, okay? I'm just sketching here. I'm not a robot. So it's going to be like that. And the same goes the other way. Here, and here, and here. And okay, this is the sine. Does the sine have an inverse function? Well, is it a function? Yes, because it passes the vertical line test. Does it have an inverse? No, because it fails the horizontal line test, all right? I mean, it's crossing all over. So you have to have a domain, a limited domain, for it to have an inverse. If you go, let's say it's coming down here. So if you go from here, let's say, for example, from here all the way to here, then it does pass the horizontal line test, okay? It passes it. So you gotta restrict the domain when you're talking about the arc sine, the arc cosine, and blah, blah, blah. I'm gonna show you the graphs of those functions, okay? Just for completeness. I don't know if you're gonna be able to see it. There you go. Pause the video if you like. I don't memorize this stuff, okay? I just don't memorize it. But you can see, for example, the arc sine in here, okay? So you're being given the value and it's going to spit out the y is actually the angle. So you don't get an angle and you get the value. You give the value and you get an angle, okay? So what is the arc sine of 1? Well, when is the sine of x equals 1? When x equals pi divided by 2. So the arc sine of 1 is pi divided by 2. The arc sine of -1 is minus pi divided by 2. So there you go in here. Okay, I know it's small. I don't know if you're going to be able to see it, but there you go. Okay. Okay, so let's practice a little bit of this. What's going to be the arc sine, okay, of -1/2? Of course, you got to restrict the domain, right? Because What is the arc sine minus half? Well, minus half is gonna be minus 30 degrees here, okay? So if you have a horizontal line in here, and you do a minus 30 degrees in here, minus 30 degrees, in here you have minus half, okay? But you also have it over here when you have minus 150 degrees. This is going to be minus 150 degrees, okay? Also in here it's minus half. So that's what I'm saying. For you to know, for the sine to have an inverse, you got to restrict the domain of the inverse, or you got to restrict the range of the function of the sine, okay? Well, actually, yeah, you got to restrict the domain of the sine. So, for example, you're considering here that the sine is going to go, for example, from the domain in here will be from pi divided by 2, or minus, right? Minus pi divided by 2, all the way to pi divided by 2. Inclusive. So it'll be from here going all the way up here, okay? And this thing sine has an inverse. Yeah. Yeah, within this within this domain of the sine, it's going to have an inverse. Okay, so considering that, it's going to be, well, minus pi divided by 6. Okay, that's the answer. What is the arc cosine of 0? Okay, so when is the cosine 0? Well, you see the cosine is 0 at pi divided by 2 and minus pi divided by 2. That's what I'm saying. So if you're going to consider from 0 to 180 degrees, our cosine is just going to be 0 at pi divided by 2. The arc tangent of the square root of 3. So when is the arc tangent square root of 3? Well, at 60 degrees, tangent of 60 degrees is square root of 3. So that's what we're going to use. The arctangent square root of 3, it's 60 degrees. So it's pi divided by 3. Okay. Keep going for now. Arc tangent 2x minus 3 equals pi divided by 4. Okay, now, okay, what do we do this? We want to get this, we want to get the value of x. So arctangents, the inverse of the tangent. What do? You just put the tangent, because remember, when you have a function and you put the inverse function inside, you get the value of x. So we want to get this, which is the x in here. How do we do this? Well, we take the tangent on both sides. Okay, so it's going to be the tangent of this and the tangent of that. Okay, so the tangent of the arctangent is just going to give out this thing here. So 2x minus 3 equals, what is the tangent of pi divided by 4? It's 1. Okay, so x equals 4 divided by 2, 2. X equals 2. All right. Now I'm going to draw a right triangle here. And actually I want to flip it. Yeah, like that. I'm going to leave it here. Okay. So Letter A. Y equals arc sine of x. Y equals arc sine of x. Okay? That means that x is a value and y is an angle. So this is y. Okay? Find the cosine of y. Okay, so if you check the sine of both sides, you're going to be sine of y equals x. Okay, now how do you do this? What is the sine? The sine is the opposite side divided by the hypotenuse. So this has to be x and this has to be 1. And if this is x and this is 1, what is this? This is the square root of 1 minus x squared. I'm just using the right triangle Pythagorean theorem, okay, to find this thing. Okay, so if this is this, find the cosine of y. Well, the cosine is going to be the adjacent side divided by the hypotenuse. So the cosine of y is square root of 1 minus x squared. Okay, that's the end of the exercise. Now, let me think here. I'm going to erase this. I'm going to leave that y in there. So y equals the arc secant of square root of 5 divided by 2. Okay, so taking the secant of both sides, the secant of y equals square root of 5 divided by 2. What is the secant? It's the inverse of the reciprocal of the cosine. Now, what is the cosine? So the cosine is 2 divided by the square root of 5. So it's going to be 2 divided by the square root of 5. This is the cosine. That means that the secant, square root of 5 divided by 2. Fine. And it's asking for the tangent of y. What is the tangent of y? Well, the tangent is going to be this side divided by this. Okay, now let's do this. It's going to be 5 equals, the square root of the square of the hypotenuse equals 4. Let's just say that this is x plus x squared. X equals 1, right? Because 5 minus 4 is 1, x squared equals 1, x equals to the square root of 1, which is 1. Is it a minus 1 in here? No, because you don't have a minus 1. You don't have a side of a triangle that's worth minus 1. So this is 1. So what is the tangent? Well, the tangent's half. Okay, the tangent of y is this side divided by this side. Okay. And I think that's it for this video. I'll see you guys on the next one.